This is lesson 1.2 from the Introduction to Algebra book. It is about powers and exponents. So lesson number 1.2, powers and exponents. This is a fairly simple lesson. I think most of you have seen it in the 5th grade, at least a little bit, but we'll talk about it in depth and particularly how it falls into the order of operations that we've begun to discuss in this block. So the first thing we'll do, of course, is our warm-up. And our warm-up today, we have one problem here that is, find the value of this expression, 20 divided by 4 plus 1, oops, not divided, okay, plus 1 minus 3. Remember your PEMDAS triangle there. And so because of that triangle space that's going to be needed, I'll put warm-up problem number 2 over here, and it is 3 times 3 times 3 equals. Number 3 is 1/4 times 1/4 equals. And number 4 is 1 times 1 times 1 times 1 times 1 equals. All right? Those are your warm-up problems. I'm going to skip one line down here and get down to here for the I can statement. I want to make sure I'm leaving enough room for your PEMDAS triangle that's going to be required right here for that first warm-up problem. In the I can statement, what we will be learning, what you will be able to demonstrate by the end of this lesson is I can compute expressions with powers. And we'll define what powers are, the different parts of what makes up a power, very soon. All right, so I can compute expressions with powers is our I can statement. Okay, so at this point I'll draw a dark green line underneath here to signify we're done with our warm-up process and we're ready to go on with our notes. You should have 2 notes sheets that need to go on your page, and just put them side by side right underneath your green line, vocab first and the good to knows next, and then we'll talk about those as soon as we get them on our sheets. All right, so you can move forward while I do my gluing if you like. That's the beauty of working on video. Or just wait for a second, I'll have them on there momentarily. Alright, so here's the first one that has the vocab we will be learning. Vocab about power, base, exponents, what it means when a number is squared, what it means when a number is cubed. If you've been working in the last block of decimals and fractions, you already are familiar with squared and cubed. Remember, we worked a lot with squared when we were doing when we were figuring out area, and cubed when we were figuring out volume. Okay, so you're familiar with those terms, and we'll just talk about how we use them as part of a power in our exponents. All right, okay, so there's our 2 note sheets that we have side by side, and as I always do, I'll take my yellow highlighter and just highlight what each one of these is talking about. And then with my pink highlighter, we'll talk about these, here we go. I hope that's visible. There we go. Okay, so what each one of these vocab words mean here. All right, so the first one here says power. What is a power? Well, a power is everything you see here. This big number, the 3, with the tiny little number up above, the 4. Obviously, these are labeled. We'll talk about what each one of those means in a minute. But all of that together is a power. All right. Sometimes people call all of this together an exponent number, but really the exponent is only referring to the tiny little number up at the top. But I know I hear people use those terms interchangeably, so just be aware of that. But officially, a number that is considered a power is made up of the base, that's the next one, and the base is the large primary number down there at the base. That would be represented by the 3 here. And then it's made up of the exponent, which is the teeny tiny number they put up to the upper right of the number together with it. Then the other two they're talking about is when a number is squared, that means it's to the second power. The exponent you would see up here would be a 2. So we'll talk over here on good to know how we would read that, but that means that number is squared. And then when a number is cubed, that means it's to the third power. You would see this base with an exponent of a 3 up there when the number is cubed. All right? So just that simple. Now, I referred to how we read exponents, and there's a couple of different ways, only because we read the ones that are squared and cubed differently. All the other ones we read the same, okay? So I think I'll take this here, and we'll talk about what it says here. So it's important to know how to read powers correctly. Now, this power here has a base of 5 and an exponent of 2. Because that exponent is 2, you can read it as 5 to the second power, but we wouldn't generally do that. We would generally read that as 5 squared, okay? And so expanded form is 5 times 5 because the exponent tells me that this is 5 2 times. That's what the exponent tells me the base is. The exponent tells me how many times I'm multiplying the base. So in this case, I'm multiplying the base of 5 2 times. So 5 times 5. So the value of 5 squared is 5 times 5, which we know is 25. All right. Well, let's look at a number that if it was cubed. So right here, I'm going to write, we'll just keep that base of 5, and I'm going to write it as with an exponent of 3. All right. So how would we read that? Well, you can read it like they said above as 5 to the third power. Okay, you can, but we probably wouldn't. What we would most likely say is simply 5 cubed. All right? And 5 cubed in its expanded form would be the base is 5. The exponent tells me I'm multiplying that 5 3 times. All right? So 5 times 5 times 5 is its expanded form, and 5 times 5 times 5 is equals 125. So the value of 5 cubed is 125. All right? Now, those are the two special ones, the ones that are squared and cubed. And like I said, you could read them either way, but you would rarely hear it that way. We would say 5 squared or 5 cubed. All right? So how about the rest of them then? Well, the rest of them, everything else, I'm going to write that. Everything else, oops, I think I forgot everything, here we go. Everything else is simply base to the exponent. All right? That means no matter what it was, if I had 16 for a base and 8 for a power, I would read, or for an exponent, I would read that as 16 to the 8th. If I had 2 as a base and 4 as an exponent, I would read that 2 to the 4th power. Okay? I should put actually power here. Usually we say that. Okay, 16 to the 8th power, 2 to the 4th power. Okay, they're all read that way. Base to the exponent power is how we would read that. Okay, so that's the basics of how we read the powers. Excuse me, got a runny nose this morning. Okay, so let's see how those look, all right? So the first thing I'm going to show you here is number one, we are going to write, we're going to, stay still. Okay, we're going to write, let's see, 6 times 6 times 6 times 6 times 6 as a power. How would we do that? Well, remember that the number that you see being multiplied is the base. How many times it's being multiplied is the exponent. And this is where you need to get some practice, because students often forget which is which. And so sometimes I will see I'll see the number of times the base and the exponents flipped. So this is where we've got to get clear on how this works, all right? So step one is, what is the base we're working with? Well, the base is the number being multiplied. So I'm going to write that right down here. Okay, I'm going to make that nice and clear there, okay? Now, the exponent is how many times am I multiplying it? 1, 2, 3, 4, 5 times. All right. So then my exponent of this power is 5. All right. So let's make a few notes so that we can remember how those work. So right here, I'm going to write the repeated number is the base. I'm running out of room, so I'm just going to write is base. All right, the repeated number is base, and I'll draw a little arrow right to that. Okay, the repeated number is base. All right, so then my pencil's back there. All right, so then the number of times the base is multiplied the number of times the base is multiplied is the exponent. Okay, exponent. All right, and so I'll draw a big ol', oh no, I want red on that one. So the number of times the base is multiplied is the exponent. Right here is where you see that. All right, so that's how we do that. If I ask you this would be considered what you see here, expanded form. So if I ask you to write this as a power, then you know the number you see here is your base, 6. The number of times it's being multiplied, 5 times, is your exponent. And now you have written 6 times 6 times 6 times 6 times 6 as a power. And we would read that 6 to the 5th power. All right? It's that simple. All right, now let's see how we would see this in action. All right, so on our second sheet for our notes, we're just going to work out a couple of practice problems. They'll be real short because exponents are pretty easy to understand. But I just want to give you some examples of things you'll see on your worksheet, things you'll be asked to do. So number 2, our second problem, is to write each power in expanded form, and I'm going to underline that, and find its value. Okay, We talked about that a little bit when we were talking about the good to know note sheet on the first page of our notes here, what that means, expanded form, and finding its value. Okay, so let's give an example here first of 2 cubed, or 2 to the 3rd power, but I would say 2 cubed. All right. If I were going to write that in expanded form, that means I've got to figure out, okay, what is my base? It is 2. So that's the number that I know is being multiplied. What is my exponent? It is 3. So that's how many times the number is being multiplied. So 2 cubed would, in expanded form, would be written 2 times 2 times 2. Okay? The base is what's being multiplied. The exponent tells me how many times, 3 times it's being multiplied. Now, this part where it says find its value means, well, what is 2 times 2 times 2? Well, 2 times 2 is 4, and 4 times 2 is 8. So that's the value of 2 cubed, right? So I'm going to take my green highlighter and just highlight this power here. Okay, this is what we were working with, 2 cubed. And I'm going to underline expanded form, that's this. And then I'm going to underline value and write that's that. All right, can you see that okay? So when it says to write something in its expanded form, this is what it means. Find its value is, well, what does the expanded form equal? That's the value then of the exponent, all right? Okay, let's do one more that might look a little bit trickier. You'll see it on your worksheets, but truly it isn't. It's the same process, okay? So what if I showed you 1/5 squared, okay? And if it's a fraction, they'll put it inside parentheses like that, all right? So same instructions, write it in expanded form and find its value, all right? Well, in this case, my base is 1/5, and the 2 is telling me I'm multiplying it 2 times, 1/5 squared. So in this case, I would have 1/5 times 1/5. Okay, and those of you that have been working in my class, we've been talking about the different ways that we can show multiplying. Because these fractions are in parentheses, I don't even actually need this multiplication symbol. But I want it to be clear to, match what you're seeing. It doesn't matter that it is there, but I don't actually need it. If it wasn't there, because of these being in parentheses, that would automatically mean I'm multiplying it. All right, so 1/5 times 1/5, okay? Remember how we multiply, just multiply straight across. There's nothing we can cross reduce here. So 1 times 1 is 1, and 5 times 5 is 25, okay? So the value of 1/5 squared is 1/25, all right? So let's make some notes on what we see here. This is expanded form. All right, and this is value. Okay, so far so good. We'll do a little green highlight on what our original power was that we were working with there. All right. Okay, so don't let it fool you when you see the ones they'll ask you that are maybe decimal numbers, or maybe they're in fractions. It's still the same process. What is your base, and how many times is it being multiplied is your exponent, all right? Okay, now there's one more kind of problem that you'll see in this lesson, and so we'll do a simple one of it. Number 3. And the instructions will say, let's get it there. Okay, the instructions will say, determine. I don't know how to spell determine. Truly I do. Let's get that out of there. That's what I love about my erasable pen. Determine which power has the greater value. 5 squared or 2 to the 5th power. Which one has the greater value? Now let's remember from up here, finding value means first you have to put it in expanded form and then figure out when you multiply all of that, what do you get? And we can't tell, well, some of you who already get this can in your head know which is the greater value, because I chose simple examples, but still you have to show your work and you have to show it like this. When they're asking you, you first got to take the first one and write it down. 5 squared equals, you have to write it in an expanded form. Well, I have a base of 5, so I know that's going to be my number. My exponent of 2 tells me it's being multiplied 2 times. So 5 times 5, and the value of 5 times 5 is 25. So the value of the power, 5 squared, is 25, right? So now we've got to find the value of 2 to the 5th power to figure out which one is greater. So that's going to mean 2 multiplied 5 times. So 2 times 2 times 2 times 2 times 2 equals, all right? So let's work across. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 36. All right? So which one has the greater power? Is it going to be 5 squared or 2 to the 5th power? Or I'm sorry, which one has the greater value? Okay, I'm going to underline that too. Greater value. Okay, greater value, it's going to be 2 to the 5th power. Okay? And students sometimes make the mistake of thinking, well, the one with the larger base is going to be the one that has the greater value. No, as you can see by how we looked at it here, that doesn't work because of, the power of multiplication, how much bigger it can get, how fast. That's not necessarily going to be true. So you have to show your work like this. You have to put it in an expanded form, show what the value is, and then you can determine the answer to this question. And we did. Okay? So that's the end of our notes portion. Pretty simple, right? And if I could have fit it onto one page, I would have. There's not a lot to show. But that's all we need to know for this lesson. So we can move on to the practice problems. Okay, so these are 1.2, for lesson 1.2, the practice problems. It looks like a lot. I've got 6 different problems here, but as I hope you could tell from when we did our notes, these problems go really fast, so it's pretty quick practice. So take a look at what you see here. For the first 2, I want you to write the numerical expression as a power. So look at this and write what would the power be. That's your base and your exponent together for what you see on these. All right. The next one that I have is write the power in expanded form and find its value. So that's when you're going to write the expanded form and figure out, when you multiply all of that, what does it equal, right? And then the very last one down here is which power has the greater value, this one or this one? This isn't the same one we did in our notes, is it? Oh shoot, it is. Sorry about that. All right, so that should be easy. As long as you get that, you get that. All right, so I'm going to put this back up here again so you can pause and work out. I'm not sure that's focused very well. Hang on. Looks like that's as good as I can get it. Okay. Okay, let's do a quick see on how we do these. All right, so first one is write the numerical expression as a power. Well, I see 7 times 7. All right, as a power, I know the number that I see is my base, and my exponent is going to be how many times it's being multiplied. It's being multiplied 2 times. So the power for what 7 times 7 is 7 squared. That's my answer. All right. Again, on this one, I know that my base is going to be 2 because that's the number that I see being multiplied. Now I need to count how many times is it being multiplied. 1, 2, 3, 4, 5, 6, 7 times. So 7 is my exponent, and I would read that 2 to the 7th power. That is my power for what I see in this numerical expression. All right? Okay, so then we get down to these. And I've got, let's see, find the power in expanded, write the power in expanded form and find its value. So to do that, I first need to know, well, what is the number I'm multiplying? It's the base, which in this case is going to be 2. And how many times am I multiplying it? Well, that's my exponent, which is a 3. So I will be multiplying this 2 3 times. Now, to find its value, I have to figure out what is 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8. Okay? So 8 is the value of 2 cubed. And some of these, like 2 cubed, you'll get to know right off the top of your head what their value are, what the value is, because you'll see them often as you move on in your math work. All right, so 3 to the 4th power. Well, 3 is my base, so that's the number being multiplied. 4 is my exponent, so that's telling me how many times I multiply it. So 3 times 3 times 3 times 3. All right, what does that equal? All right, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. All right? So 81 is the value of 3 to the 4th power. All right? Okay, so now we got one of these little fraction ones. I threw one of those at you in your notes so you'll know what it looks like. Okay? And so 1/3 is what I'm multiplying. And this exponent here tells me how many times I'm multiplying it. 3 times. So I've got 1/3 times 1/3 times 1/3. And remember what I told you before. You could put the multiplication symbol in between if you want, but the parentheses themselves means multiply. So we don't have to. All right? So multiplying fractions means we just multiply the numerators across, multiply the denominators across. There isn't any cross reducing we can do here. So it's going to be 1 for the numerators, and 3 times 3 is 9. 9 times 3 is 27. So 27 is my denominator here. And so that means that 1/3 cubed has a value of 1/27. All right, that's our answer. Okay, all right, and then down here where we're doing the comparing, we've got to show our work, which one is greater. So we will put 5 squared, get in there, equals. So 5 is our power. We know that's what's being multiplied, and we're multiplying it 2 times. Okay, which equals 5 times 5 is 25. All right, and on this one we have 2 to the 5th power, which means we're multiplying that 5 times. So 2 times 2 times 2 times 2 times 2. Did I do that? 1, 2, 3, 4, 5. Yep, equals. All right, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 30. What did I say? 32, right? Yeah. All right, so which one is greater? Has a greater value? 2 to the 5th power. All right, so those were your practice problems. That should have been pretty easy for you. Your worksheet for today is going to look pretty much just like what we did in our notes. The top portion here is talking about write the numerical expression as a power. Okay, so you're just going to figure out what's your base and what's your exponent and write it as a power. That's what's happening with all of these. All right. Down here in this middle section, it's asking you to write each power in expanded form and then find the value. So you'll write the expanded form here and then figure out what does this equal down here. Then that's the value of that. Refer to your notes. We did many of these. Okay, and then at the very bottom, it's asking you determine which power has the greater value. You'll show your work so you can tell on each one of those. This last one says list the following from least to greatest. It's the same as determining which has the greater value, really. You have to show your work for each one of these powers, expanded form and value, and then you'll be able to list these powers from least to greatest. All right, that's all there is to the worksheet. So that leaves us with the showing you the exit ticket. And let's zoom in on that for you. Exit ticket, I don't give you the answers for that. Your teacher may use them in other ways. You may use it as, oops, too far, sorry. You may use it as extra practice. So pause here if you want to use that as extra practice. Okay, so that's the end of lesson 1.2. Remember, the only way to learn math is to do math, and mistakes are proof that you are learning.